Okay. How are we doing? Good. This is, I know, the last thing between us and lunch, but I am excited for this panel. The title's up there, Interface of Natural Resource Management for Working Lands. My name's Kim Novick. I'm a professor at Indiana University. I'm also on the CLT. I'm excited for this panel because the fact that we have a panel discussion that has the word working lands in the title represents a bit of a step for the CASC, right? So the CASC system historically has supported adaptation science for natural and cultural resources. And working lands, our croplands, pastures, et cetera, have sort of been a little bit out of scope. But we know, if we live in the Midwest, that it is very hard to ignore our working lands. If you drive 10 minutes out of almost any town in the entire domain of the Midwest CASC, your view will be dominated by two species, right? Corn and soy. And so it is, on the one hand, hard to ignore the working lands, but I think also unwise to when we think about adaptation science. So I'm going to kick us off by showing just two pictures to illustrate this point, and then I'll introduce the panelists one by one as they come up to make remarks. But I wanted to show you this picture. It's actually a painting. It's painted by an artist named Sean Miller. He lives in Washington, Iowa. I stumbled across his work at an art fair in Bloomington a couple of years ago when we were working on, at the time, a white paper report focused on nature-based climate solutions. Mallory and Caillou were part of that effort, and we needed a cover image. And there it was, right, at this art fair, because what this image shows, and it is of some Midwestern landscape, is just how spatially connected, right, our forests and our farms and our waterways are, right? And the notion that what happens on farms affects water flows and the quality of water in our rivers, streams, and lakes is probably not news to most of you, but it is important to remember. There's, of course, another fluid that flows across the landscape, which is the air. And alterations in land use or management of forests and farms can affect the energy balance in ways that then get affected across the landscape by the air, right, with really pronounced effects on microclimate, right? So these are spatially connected landscapes, and they are also temporally connected. This is an image pulled from a paper we wrote about oak decline a few years ago. But you know, the eastern and midwestern United States has experienced this really profound shift in land use over the last few hundred years. This image describes what happened in Indiana. For Illinois, for the pre-colonization phase, we probably have to have a few more prairies and wetlands in there, but the story is pretty much the same, particularly in Indiana. Forests dominated for millennia. They were managed ecosystems managed by indigenous tribes using tools like selective harvest and prescribed fire, and we had this rich mosaic of uneven aged forests that were virtually erased rapidly from the landscape during colonization, where Indiana, for example, lost 90% of its forest cover. And then something interesting happened over the last century, which is that many of those forests returned to the landscape. Not nearly all, but many. What really happened was it was a combination of climate, right, the Dust Bowl era drought, and economic factors that generated widespread cropland abandonment in the United States. So I think it's important to remind ourselves of that land use history because it all happened so quickly, right? This is really just a blink of an eye, and these landscapes are dynamic. Forests become farms, farms become forest, and so on. So with that, I would like to turn it over to our panelists. We have three with us today. And we're going to hear from them. They're going to give some opening remarks. And then we have a few sort of set questions, but I'd love to hear perhaps even first, before we get to those, sort of what you all want to follow up on after you hear these about 5-minute presentations. So our first panelist is Caillou Gone, who's based here in Illinois. Hold on just a second, I've got some bios here. Caillou is the Leverick Professor and Founding Director of Agroecosystem Sustainability Center at Illinois. He has expertise in agroecosystem modeling, carbon cycling, and remote sensing, and he has developed an agricultural prediction platform that is used by the government and farming communities to advance climate-smart agriculture policies and to enable farmers to shift towards sustainable practices. So let's welcome Caillou. I'm going to introduce and then you talk. So if you want to come up, Caillou, do you want to give your slides? Oh. I think we'll do it this way. Yeah, I'll give a little longer introduction.
Sure.
Yeah, that way they don't forget.
Okay, got it.
And you can just advance. Your slide should be next.
I see.
Fingers crossed.
That's
not
right.
you, though.
Yeah.
That's Shibu. Now, where did yours go? I see. All right, we'll have to reorder a little bit. Okay.
Okay, got it. Okay.
Okay.
Sure. Yeah, it's a great honor to be here. And then I have heard about the center effort for a long time. I have my former department chair, Dr. Jeff Brown, and then my colleagues, a couple of my colleagues here that running the program from the U of I side has been really a very important, interesting thing that I keep pay attention, and I'm very glad to be invited. So I'm briefly going to talk about some of my work. As Kim already mentioned, majority of the U.S. Midwest landscape are conserving, and so I'm going to talk a lot about that. So if we thinking about the whole planet, then zooming to the Midwest, and then we know that we are producing 1/3 of the global corn soybean. And then if you continue zooming to Champaign, this is where we are. You know, the central black part is our campus, and so we are in that part. But outside of the campus, each individual parcel refers to a specific farmland that grow either corn or soybean primarily. And then every farmland actually have their own practice. Because the farmers actually use different management practice. And then, as a matter of fact, 70% of the land in Champaign are rental. So the farmers are not working their owned land; they are actually rented the land to farm. And then so with all of that being said, there's a lot of the questions that actually connecting these different components, and especially food, water, and nutrients at the Midwest. And then our system, as already Kim mentioned, there's a progression of deforestation converting into the prairie land, natural prairie land into the intensive agricultural land, and even more so, some of you may not believe this, but more than half of our land has artificial pipes beneath to make the land drainable and arable to take the best advantage of the soil type and the SOC. But then we actually build the so-called tile drainage into the system. And then these actually significantly modify the biogeochemistry, water cycles, and the crop growth. And then some of these issues actually creates environmental problems because we generally put too much fertilizer into the system, and then a lot of the fertilizer, nitrogen fertilizer, cannot be used, so they actually flow into the water body, flow into the Gulf of Mexico. And then so in a lot of our work, we focus on two major things. The first one is really doing a lot of the sensing. And so, in other words, that if you want to measure things, one way is you go to the site, you measure on the particular, doing a particular leaf samples or soil samples. But what we do is we also try to think about how to do that in a much more scalable way, and then covering large scale areas. So some other professors here, we're also doing a lot of remote sensing, but we are trying to connect the dots from the ground level to the intermediate scale to the ultimately satellite level. And then we focus on both crops and then management practice as well as the environmental conditions. And then after you have a lot of the data set, what we also do is we actually build some of the process-based modeling to understand other components of the system that cannot be directly observed. And in our case, we use the model called ecosys to really simulate plant growth, soil interactions, and then including quite sophisticated biogeochemistry, carbon nitrogen cycle, water cycle, and then plant growth, and then how this whole system function. And then when we're doing this, we know we have a lot of the data sensed gathered from the space. So what we do is we call the model data fusion, which is integrating basically how the models and then data can deeply integrate together to generate some insights. And then in this particular case, some of the AI tools will be leveraged. So I'm going to give you one particular example. This is a technical effort, but then that leveraging some of the AI tools bring different diverse data streams of data into the model. I will leave it there for the technical part, but what I want you to zoom in is what you can see on the right side is that we actually understand what's the change of the soil organic carbon change in the soil happened in the past decades with the current practice. And then so in other words, a lot of the places are losing carbon, some places are gaining some carbon. But then all of that is indicating that the whole system is changing. And then these SOC dynamics cannot be directly observed from satellite. So you have to integrate satellite information of photosynthesis plants with a sophisticated model to infer something out of this. So, but I think these technology and scientific advances allow us to start to look at deeper about what's going on inside the soil that satellite cannot sense. But it's very critical to understand different management practice, their implications to our land. Some of the efforts that we're also very interested in doing is thinking about integrating all of them together, but from the perspective of policy design. And then, as you all know, that the farmers doing individual practice at their field, but if you want to have a large-scale change of the practice or improve the management, one important way is to go through the government policies. And then, in the current scheme of current administration, it's probably hard, but I think what we're trying to really think about is how we add more of the scientific evidence and guidance into the development of the current conservation program of the government, current crop insurance program and then how we actually all bring all of them together to help guide and then make more informed decisions. And then so again, I stay my talk at a pretty high level, and then just to give you a sense about what I'm doing, and then happy to engage more discussions if you have further questions.
Thank you, Caillou. Our next speaker is Shibu Kar, and we are going to have to see. The slides are a teensy bit out of order, but that's okay. We will have Shibu's first slide, and then we'll have to see that all again quickly to get to his next set. But our second panelist is Shibu Kar. He is Assistant Dean, the Natural Resources Environment. He's Assistant Dean, Natural Resources, Environment, and Energy Program Leader, and Associate Director of the Illinois-Indiana Sea Grant Program. Dr. Kar provides strategic and functional leadership for extension specialists, educators, and field coordinators to design and evaluate strategies that encourage the adoption of more nature-friendly, environmental, and energy-related best practices, working among farmers, businesses, and communities. So with that, the floor is yours.
Hello, everyone. Glad to be here. Thanks, Kim, for the nice introduction. So I'll be talking more from the extension and outreach perspectives. As we know, in every land-grant universities, teaching, research, and extension. So extension is one of those three pillars, right? So it is important that the research findings and the knowledge that we develop in the universities, that it's being communicated for the betterment of the communities and then environments that they live in. So as a program leader for our natural resources, environment, and energy program area that I lead statewide in Illinois. So I'm gonna kind of share a little bit of that perspectives, like some of those key program areas that relate more with the climate change.
Let's see. Sorry, yeah, I didn't do the best job putting the slides together.
Okay, here.
Okay.
Okay. So for our Illinois extensions, the mission is kind of to extend this research-based knowledge to the communities and the other stakeholders, more implementing those research findings, for our healthier ecosystems and also for better living of the communities. And it is not state-specific. I mean, we focus more on the state, but there are some, Midwest and North Central region collaboration that we do as well. And so here on the statewide, kind of we have 3 regions, 27 unit office. So we have extension presence throughout the state in 102 counties. And we have 27 extension offices, and we have presence in every county. All of our extension staff and the educators, they are kind of connected with the campus, and they are taking this knowledge and disseminating that to the communities and other working with other partners, to implement this. And so in my program area, so we are focused more on the healthier environment and ecosystems and to support the quality living and resilient communities. So these are the kind of primary kind of flagship program areas that in my program area that we focus more on, but I'm gonna kind of highlight a little bit more on the top three on the climate resilience, water resources, and the extension forestry as they relate more with the working lands. So on the climate resilience side, from our Illinois extension, this is one of those kind of strategic kind of decisions and priority for us to integrate all our extension programming as we do the community outreach and stakeholders involvement. That we do this through the how do we integrate climate change topics within this each of this program area, whether it's agriculture or environment or family consumer science or the youth focused programming or health disparity aspects. So part of that, I think we did a kind of survey for our extension educators and other staff throughout the extension systems to, based on that, about their interest and barriers to integrate this, climate change topics into their programming area. Based on that, we developed a training program for all the extension staff to sign up and then get that training so that they can be better equipped to implement this kind of topic areas or integrate that into their own programming area. So that has been kind of a very significant accomplishment. I would say about 45 our extension staff got that training so far. It's online based kind of, three kind of segments of the modules that we developed, and it's been pretty successful. And many of these staff that after that training, they are integrating that climate topic into their own programming area more and more. And also, interestingly, many other states, including at least 5 states, they showed interest to take this training to their extension systems. So at least 5 other states are integrating this into their extension systems, which is a exciting things for us too. And then climate tools workshops, in collaboration with the Midwest Climate Hub and our state climatology office and our extension folks, we put together some climate tools workshops and more focus on the growers, producers, and natural resource professionals throughout the state. And again, making them familiar with the climate tools and how to integrate that as to make that informed decisions. And we have been offering a webinar series by state with the Indiana and Illinois. We did some by state kind of webinar series. And also we have a everyday environment webinar series on our own, and where we had that whole season of that webinars focus more on the climate change and integrating many of these climate topics into these discussions. And then the other piece on the Climate Stewards program in collaboration with the UC Davis, California folks. So we kind of collaborated with them and adopted their Climate Stewards program and tweaked that for our own, Illinois aspects, many of these components. So I'm going to talk a little bit about that part. So this Climate Stewards program is more targeted towards, the communities in the state. They after that training, they become the ambassador, climate ambassadors, to take the local initiatives, work with the local communities and municipality leaders, take on some of these kind of, climate initiatives in terms of the adaptation, mitigation, or resilience. So that that training has been, we piloted it like 3 cohorts, about 60 kind of stewards kind of got trained, and they have been kind of doing some of this work in the communities. So this course is more focused on the climate communication, climate science, and also local actions. So, I mean, we have that kind of a robust program, and we are continuing that. And we also plan to kind of maybe disseminate that through the other organizations like the museums or environmental centers and nature centers and train them, and possibly they can train their own audience as well. So that's, and we have our climate resilience specialist Jess Radnick here, so she's kind of leading that effort now. Water resources aspects also, I mean, I know we are short in time, so I'm not gonna elaborate much, but I'm happy to talk some of this more in detail. So along that climate aspects, I mean, we've been doing lots of outreach on the watershed stewardships programming, landscape programming, and also green infrastructure in terms of the climate resilience and erosion control, and also nutrient loss reduction strategies. We have been implementing many of these best management practices in the crop fields and working with the farmers, on the riparian buffer aspects, and also cover crops and carbon sequestration, as Kai was mentioning. Many of those kind of best management practices, we have the outreach associates who are working with the other growers and farmers on implementing that part. And I'll end with this. On the extension forestry is another key program on the working lands aspects. So we have been offering and involving the woodland owners, giving them the training on best management practices of managing the forest, coming up with the forest management plan, invasive management, and the ecosystem restorations, prescribed fire, and also we are hosting symposium on the invasive species management, and so those aspects. And there have been some applied research. Some of our extension forestry specialists are involved in carbon sequestration through the woodland management, and through that and also agroforestry is another area that we are trying to grow, and in urban areas as well, on the more on the carbon focus, and also restoration aspects. So with that, I'll be happy to engage in more conversation around any of these or beyond that. Thank you so much.
Okay, thank you, Shibu. And our last speaker is Mallory Barnes. Mallory is an assistant professor at the O'Neill School of Public and Environmental Affairs, also at IU Bloomington. Her research and teaching focuses on environmental informatics. Let's see if we can get to Mallory's slides. There they were. Okay, her research focuses on environmental informatics, remote sensing ecohydrology, natural resource management, ecological analytics, and geographic information systems. The work serves to improve our understanding and prediction of environmental changes in response to climate change, ranging from individual plants to entire ecosystems, with implications for agriculture, water resources, and biodiversity.
Hi everyone, I'm really excited to be here, and thank you for inviting me to speak on this panel. I haven't been to this symposium before, but I'm excited to get more involved with the Midwest CASC because my PhD student, Cassandra Key, recently got a fellowship. So I will be here more often in the future. Yeah, congratulations, Cassandra. So I'm just going to talk about a couple threads of research that we have, and here I interpreted working lands a little bit broadly. So I'm going to be talking a little bit about work in forests that we do that's relevant to climate adaptation, and then I'm also going to be talking about agricultural systems. So the first thing is some recent work that we did. Oh, I didn't mean to do animations. Here we go. That we did that is really relevant to climate adaptation. So this work was recently published in Earth's Future. And so this was actually originally motivated by this idea of the southeast warming hole, which if you haven't heard of it, it's this area in the southeast United States that hasn't been warming up as fast as everywhere else. In addition, at that same time, this really interesting history of land use change that Kim alluded to or mentioned earlier is that there were tons of trees that got planted in the early 1900s and grew back around that time. And so with this work, we were trying to assess whether the warming hole was related to this really extraordinary history of reforestation. If you are interested, you can look at that paper, but what was exciting about this work and what some of these offshoots from that work are going to be is that we found that forests do cool the surrounding air, and throughout this work we developed new methods to quantify that local cooling effect of forests compared to non-forest. And so we can think of that as kind of a local climate adaptation potential of forests. And so we use a combination of methods in my group. We use satellite data, and we also use flux towers, which are kind of at the ecosystem scale, and they measure the exchange of water and carbon. And so from our satellite data, we were able to see that forests are 2 to 5 degrees Celsius cooler than the surrounding non-forest areas, which is a huge difference. And in one of the first times to show this, we were able to use that flux tower data to show that this cooling effect also extends to the air. It's a lot smaller in the air, it's about 1 degree Celsius, but that's really important for people because people live in the air, right? We don't live on the surface. And so for there to be a climate adaptation benefit of forests that we can start trying to quantify and look at how that climate adaptation could look in urban areas, for example, it was really exciting to be able to show that this does extend to the air. So some work that I have some funding in to try and do in the future is extending this work to urban areas. So looking at urban green spaces, using thermal UAV, and really trying to see how much cooling can we get from forest patches of different sizes in urban areas, and what type of cooling benefit would that provide to areas not just directly in the green space, but maybe even slightly around it. So another kind of example of the work that we've been doing is some of these adaptation co-benefits of different climate smart agricultural practices. So we have a NSF DICES project led by Kim that is looking at cover cropping, and a lot of this work is kind of in this frame of nature-based climate solutions. And so cover cropping has a lot of really important ecosystem services, things like water regulation. It can buffer the soil from extreme temperatures. We can protect the soil by reducing erosion and improving structure, and it can also improve nutrient cycling. And so my PhD student Cassandra will be presenting a poster about this work where we have paired flux towers in adjacent cover cropped and non-cover crop systems, and we can really try and understand some of the climate mitigation and adaptation benefits of these types of practices. One thing though that I wanted to talk about that's really exciting and new is that our postdoc Shen Wang just had a paper come out about the climate benefits of no-till agriculture. So no-till, you just leave the tillage on the land. And Shen looked at the potential mitigation benefits of this with relation to albedo. So albedo is that planetary reflection. If you have something that's lighter in color, it reflects more of that energy that comes in back to space. And so that can be a pretty big climate mitigation benefit. And so Shen was able to quantify this benefit for Midwest agro ecosystems and also convert that into carbon equivalents to see what are some of the realized climate benefits that we already have from no-till agriculture, and where might we try to optimize no-till agriculture to get more benefits as well. One other aspect of my work that I wanted to talk about is using tools that bridge these scales. So particularly since a lot of this work is in the context of nature-based climate solutions, that's really about mitigation and potential carbon sequestration. But a lot of these practices have substantial adaptation co-benefits. And so if we want to value something, we have to be able to measure it. And the way that we do that in my group is some of these like cross-scale mixed methods type of work. So I mentioned these already. We have flux towers that are providing this fine scale data. We have remote sensing, which is more my background and expertise, that's looking at satellite data to really look at landscape scales and larger. And then in my group, a lot of the time, the way that we integrate those two types of data is using things like machine learning and other quantitative informatics approaches. So this really helps us have these scalable types of insights and maps and stuff like that, like Caillou mentioned earlier. And so hopefully that can lead to more actionable research. So with that, I just wanted to talk about briefly about how I see these mitigation and adaptation pieces fitting together here. So we really want to, we already rank things by mitigation potential, but the adaptation piece is really important as well. We try to look at that local adaptation piece in forests, and then we also look at the potential adaptation of things like cover crops. And so the idea would be hopefully eventually to have these more holistically informed nature-based climate solutions that can account for both of those types of benefits. And for us to be able to account for those climate benefits, we have to measure them. So I'm excited to engage more with you as part of this panel. Thank you.
Okay, looks like this is working. So what we do now is we move into Q&A for the panelists. And as I mentioned, we had a few sort of prepared questions, but since time is short, since the flow of information this morning has been largely this way, I'd love to just see if maybe you all have some good questions for our panelists first. I suspect that you do. And so I would like to invite you, if you do have a question, I don't know if there's a mic. Okay, you raise your hand and the mic comes your way. These will be questions for the entire panel or for one of the individual panelists.
Thank you for this really wide-ranging and highly relevant perspective. And Kim, for your opening remarks about how, if we're thinking about natural and cultural resources in the Midwest, they interface with working lands in really interesting and productive ways. I wanted to talk, following on the conversation about U of I extension, but the question should apply to all of you. And I'm thinking about it from the Climate Adaptation Science Center's perspective. We do a lot of, or we're seeking to do a lot of support and professional development for graduate students and for postdocs in the production of what we might consider adaptation scientists. What advice would you give to the CASC about what those future leaders might need, both in a science development and research setting, like what are important questions, but also how they might interface with other adaptation practitioners or what they need to know when they're confronting other people who are working on climate issues in broader society as it relates to, say, working lands or natural areas. Can you put on your advice hats for those of us trying to steer the CASC, please?
Sure. Good question. Thank you. So I think it is critical that extension and outreach is kind of being considered as, and being integrated more within our kind of a research and implementation aspects. So we are trying, and this is kind of an ongoing thing. So some of this climate training, like the online based that for the staff that we are doing, so there could be a way of tweaking some of that, doing that more for those kind of prospective professionals, because I think especially when we face this kind of implementation aspects of talking about the climate change, so communication piece is an important aspect, understanding the audience and because community to community, if they're not receiving it, if they cannot connect, I mean, whatever information we provide, I mean, it is not being effective. So that's why we have been focusing more on that, communication aspects more, and also this create from the research perspectives as well. I mean, for example, as I showed, I mean, we have presence of extension staff, throughout the state, and that's the case in many of the states too, in the land-grant universities. So I would encourage the researchers, and that's what I've been also trying in our campus to utilize that resource, those connections of the extension, the staff. They might be they're looking for those opportunities of campus connections, and they might be able to help you in data collections or connect with the right other partners or if you're looking for certain research topic areas that applied research wise, they should be able to kind of connect, or provide those data locally. So that's, I think, another important aspects. And also the other thing I would say is in terms of integrating maybe the courses that we are teaching. So that's something we have been also trying, like, can we integrate some of this outreach or connecting some of those field-based examples of, and integrating some of the extension educators or the specialists, part of those kind of as a guest lecture or some of those extension components within those classwork. That way, or a field visit or a couple of field visits with that extension educators so that they know how to implement this into the field. And they find the relevance of their research into the practice. So I think those are the few of the kind of ideas that in my mind. Thank you. Anybody else would like to add?
So I have been very closely working with Professor Jonathan Coppers, who is a policy person he has been in the Congress working for the past 2 farm bills for the Ag-Senator Committee. So one thing that he and I are very motivated about thinking about is, as you all know, Farm Bill or most of the U.S. government bills, they are developed by young professionals working in the congressional office, work for the senators and representatives, and then we are envisioning like these people, most of them are actually doing the writing of the bills and stuff. Can we actually thinking about feeding the future workforce of those people actually has the ability to talk about the policy, has the ability to talk about the science, and almost seamlessly can translate both. And that's sort of really the hope, because when we hope to see is down the road when we start to, there's a new round of farm bill that, on the development, and then the debate or the discussions is really about, is managed or is guided by the people that actually can speak about both language. So, I think it's a high level thing, but think about how we actually train the workforce, and then think about the agriculture policy or how farming is done, as well as how the science is done is extremely critical. So, yeah.
I just have, this is a little bit different, but as an early, career person, I think working in such a wide-ranging space as this, climate adaptation field can be it can be hard to find your identity. So I would just suggest maybe some sort of identity mapping type exercise for some of the earlier career people, because how do you know who you are? What do you bring to the table, and when can you actually more leverage others' expertise? What do you need to know to be the person in the room, and then what can you rely on your colleagues for? And so I don't have a great concrete example, but some sort of identity definition exercise I feel like could be helpful.
Maybe even for those of us that aren't early career. Right? Who am I? Anyways. Right. Other questions from the audience? Great. Yeah.
Really great to hear about all your work. I do know and recognize that we're, of course, a very agricultural heavy university and appreciate all the extension programming that's offered. Have any of you thought about more of the connection with local policymakers? I mean, of course, we rely on funding from the federal government, but there's, at least in my experience, a lot of local people who are super interested in climate mitigation. Like, for example, the city of Urbana here has programs for homeowners to get a reimbursement for plants for rain gardens. And I know we have somebody mentioned the Red Oak Rain Garden. And Mallory, I think you mentioned that you are going to be working with urban tree cover. So are there other thoughts on how we can get more buy-in from folks within local government as well?
Yeah, I'm happy to talk a little bit about that. I will say that one of the things that is related to that identity aspect I was talking about earlier is that I always try to figure out what exists and what can I leverage, like in terms of these partnerships, right? It can be really hard to forge partnerships on your own, particularly if you're beholden to the 3-year grant cycles. And so at Indiana University, we have something called the Environmental Resilience Institute that's got some really awesome programming, including this program where they send people into local municipalities that are working on urban tree planting plans. And so they work with them to make equitable tree planting plans, and they send in a climate fellow that spends the whole summer working with those municipal partners. They have programming for those fellows about how to work with local municipal governments. And so it's this really nice integration between the local policymakers who are interested in implementing urban tree cover, and then the Environmental Resilience Institute provides the funding and also a student who is there to help them enact those plans. So I think that's one example of how that can work really well. But I think that takes a lot of infrastructure, that takes a lot of time, and so again, kind of trying to leverage things that are already there has been what has, I build my grant off of that, those existing programs.
Yeah. Good question. So on the landscaping aspect, so from the Illinois Extension, we have been kind of, as I mentioned, I've been trying to gear up on that landscaping programming, like which is kind of a more slowing down this runoff water and and planting the native plants and design in a way so that we can slow down the this from the extreme precipitation and reduce the flooding and stuff. So. And we do have some, we have been working with the local governments and other partners throughout the state. And by the way, so Red Oak Rain Garden is one of those landscaping garden that we have on campus. I would encourage you, if you have time, to check that out. It's some on the close to our that greenhouses that you see in that site. So like in the Kane County and the Queens area, we do have a couple of other rain garden demonstration rain gardens that set with to the partners and donors and some local governments kind of support on that part. So we are trying to kind of work with other municipalities and on those aspects as well. And we have our Master Naturalist volunteers. We have about 900 throughout the state volunteers. So we utilize some of these demonstration plots, giving that opportunity for those volunteers to serve on the conservation aspects as well. So and we have more than 2,000 master gardener volunteers. So some of them are also interested in working in these opportunities. So yeah, it is an ongoing thing. So I know we are kind of gradually growing on that part too. Thank you.
Not much to add, but I think as we know, the landscape is primarily conserving, so there are huge farmer communities and farmer groups, and then there is also check-off programs, which means that every dollar bushel, every bushel of conserving you sell to the farmers basically pay like a tiny bit of money to a joint pot of money. It's called check-off, and check-off actually program funds quite a bit of active research in our state, and these are the farmer communities and the farmer groups. So in other words, that thinking about how you think about climate change adaptation mitigation policies or from the local level or changes, and these groups, these farmer groups, are actually already doing quite a bit of work.
We've got a question online here. How would you suggest regional collaboration between agricultural research and more natural landscape research? What collaboration should happen for this network to succeed and avoid silo efforts, specifically maybe with attention to connection to extension or other outreach efforts?
Well,
I think we can make sure we heard the question and maybe expand it just a bit, but just sort of connection between crop science and research happening in natural landscapes. And I think because that one stumped the panel, I'd like to, or 2/3 of them anyways, maybe just thinking more about how the work that you do intersects across sectors, whether it's traditional or across the landscape, really bridging cross-sectoral connections with your work. Okay.
Yeah, thanks. That's an interesting question. I think, we're not at a land grant institution, so we don't have like the hardcore crop scientists at Indiana University, but I do think that there's a lot of connection there in terms of the, again, scale, right? There's like precision agricultural techniques and things that are remote sensing at these finer scales, but I think those techniques can be applied in other situations, and also we can gain a fine scale understanding of some of things like mechanisms or what's going on at this really fine physiological scale, and then using some of our techniques in these less managed landscapes. I don't know if like natural landscapes are, they're not completely untouched or anything. Then we can try and see how some of these processes might scale up, or we can do the reverse and see some of these bigger patterns. Why might we be seeing what we're seeing? And we can sort of try to delve into the mechanisms with some of these more specific agricultural crop type techniques. So that's where my head's at least initially with that question.
From the extension side, I think, that's an important aspect that multi-state collaboration. So I'm actually currently serving as the chair for our Extension Agriculture and Natural Resource Leaders, Program Leaders Group, and which is North Central Region, 12 states in here. And we meet monthly, and we also do in-person meetings and discuss many of these potential collaboration. So we are trying to more on the extension end. I mean, we are trying to develop the best management practices and pull together our expertise, and sometimes we may not have the right staff or right specialists or educators. So, but if we do have, someone working on the pollinators issues, for example, so we are trying to connect them with the other states, that kind of expertise, so that they can regionally they can pull together some other regional kind of programming on that part. The other aspects I would say Sea Grant. So I also oversee as associate director. As an associate director for our Illinois Indiana Sea Grant, I oversee our Illinois part and Illinois Indiana. So that's another thing that we do have in the Great Lakes focused multi-state kind of ongoing programming on the research side and also outreach aspects on the coastal resilience. So, but I feel like that those kind of approach could be expanded more, and also there is an opportunity for the campus-based researchers and to integrate more, on the aquatic or the fisheries focus, kind of, or the water quality focus or coastal resilience focus work to do together to integrate that more in the multi-state. So I'll stop there.
I only have one small addition. So, one example that I see that naturally connect agricultural land and then the natural land. For example, the biodiversity side, birds, when they migrate, when they decide where to go, they look at the whole landscape, and then so sometimes it's very hard to just say, okay, we are only doing the biodiversity of bird on natural land or agricultural land. And then, as a matter of fact, the biodiversity scientists that I collaborate with actually have to look at the whole landscape. And then I think there's a lot of interesting questions that regarding on that part that actually leads to very interesting collaboration. And then so, to a certain extent, this is at least one very important topic, that biodiversity, the agricultural land, biodiversity, people have a lot of questions and concerns, and then how we actually connect with the natural landscape, biodiversity research. I think that particular topic is something that I quite interested in. I work with Professor Michael Ward in our department, exploring meaningful ways to collaborate. So it's quite interesting.
Gotten the signal to wrap up, so we're going to go ahead and do that because I know everybody's getting hungry. If you have other questions, maybe you can catch the panelists on the way out. Why don't we give them one more round of applause?